In this module, we will learn about arithmetic progressions. First, we will discuss what the meaning of arithmetic progression is. Arithmetic progression is a sequence of numbers that has a constant difference between every two consecutive terms. In other words, arithmetic progression is a list of numbers in which each term except the first term is the result of adding the same number called the common difference to the preceding term. Let us take an example of arithmetic sequence. The sequence 5, 11, 17, 23, 29, 35 is an arithmetic sequence. Because the same number 6 is added to each term of the sequence to get the succeeding term. This fixed number is called the common difference of the AP. Remember that common difference can be positive, negative or 0. Let us denote the first term of an AP by A1, second term by A2, nth term by AN, and the common difference by D. Then the AP becomes A1, A2, A3 up to AN. So A2 minus A1 is equal to A3 minus A2 is equal to AN minus AN minus 1 is equal to D. This means A plus D, A plus 2D, A plus 3D represents an arithmetic progression where A is the first term and D the common difference. This is called the general form of an AP. Arithmetic progressions, AP, can be of two types. Finite AP. This type of arithmetic progression, AP, has a last term, and the number of terms in an AP is fixed. For example, the cash prizes in rupees given by a school to the toppers of classes 1 to 10th are, respectively, 200, 250, 300, 350 up to 750. Infinite AP. These APs do not have a last term, and the number of terms is not fixed. That is why it is called as infinite AP. For example, 100, 70, 40, 10, and so on. In this AP, there is no last term. Now, to know about an AP, what is the minimum information that you need? Is it enough to know the first term? Or is it enough to know only the common difference? You will find that you need to know both the first term A and the common difference D. If the first term A is equal to 5 and the common difference D is equal to 2, then the AP is 5, 7, 9, 11, and so on. And if A is equal to 5 and D is equal to minus 2, then the AP is 5, 3, 1, minus 1, and so on. So if you know what A and D are, you can list the AP. Now, if you are given a list of numbers, can you tell whether it is an AP and then find A and D? For example, for the list of numbers 6, 9, 12, 15, and so on. Since A is the first term, it can easily be written. Here, A1 is equal to 6, A2 is equal to 9, A3 is equal to 12, and A4 is equal to 15. We know that in an AP, every succeeding term is obtained by adding D to the preceding term. So, D is found by subtracting any term from its succeeding term, that is, the term which immediately follows it. We have A2 minus A1 is equal to 9 minus 6 is equal to 3. A3 minus A2 is equal to 12 minus 9 is equal to 3. A4 minus A3 is equal to 15 minus 12 is equal to 3. Here, the difference of any two consecutive terms in each case is 3. So, the given list is an AP whose first term A is 6 and the common difference D is 3. In general, for an AP, A1, A2, A3 up to AN, we have D is equal to AK plus 1 minus AK, where AK plus 1 and AK are the K plus 1th and Kth terms respectively. To obtain D in a given AP, we need not find all of A2 minus A1, A3 minus A2, A4 minus A3. It is enough to find only one of them.